Hello, my name is DeHoffman, and I am doing the Voltmeter project for my ECT295L Applied Project Lab with Professor Madi Nagzad. The project overview is the objective of the project was to build a digital voltmeter that measures DC voltage and displays the value measured on the organic light emitting diode OLED display on the ARM board. The voltmeter has a measured range from 0 to 20 volts. Because the ARM board runs off of a 3.3 volt input voltage, an interface circuit was necessary to lower the voltage before that voltage can be fed to the ADC channel. The goal was to create a circuit that changes the input voltage range from 0 to 20 volts to approximately 0 to 3.3 volts. Before we actually did any of the build, we went into the multisim and placed the opponents into the multisim program to compile it to make sure that everything runs according to plan. The photo on the left side has the values that according to the materials list was needed. Now the photo on the right side has the actual value of each component that I used, such as the R2 resistor says it's supposed to be a 4.7k ohm. The actual value that I have on my R2 resistor is a 4.657k ohm. I did this with all of the resistors and capacitors, and there is a small change on the op amp that I used. The asking op amp was an LM358AN, and I used instead a LM358N. As you can tell, with both of the potentiometers at 75%, there is a 0.0 about 0.03 volt difference. On the hardware construction, I went through many configurations in the construction of this build. I eventually settled with the original configuration, but used, like I said in the previous, the LM358AN op amp instead of the LM358AN op amp. As you can see, the photo on the left is the original build, and the photo on the right is my completed build at the end of the process. The next step in the process was to build the program, the VI program, through LabVIEW software. The original VI program for the voltmeter had a few challenges that many of us were encouraged to find and modify. While I had no issues with the LabVIEW software and the installation of the VI program, I did have challenges with the formulas that would help display the voltage between the DMM and the OLED. The changes, modifications, and troubleshooting. During this stage, I was able to find the differences that I needed on the formula module. I used the VI program that the professor sent out in the postings for week 6, and changed the formula there to read volts equals 20 divided by 3.00095 times X. This provided me with a closer voltage reading between the DMM and the OLED in both the high and mid-range readings. As you can tell on the left-hand side, that is my completed program installation. On the right-hand side is my high value, while the DMM is reading 19.98 volts. The OLED is reading 20 volts. For the mid and low range, the DMM is reading 11.32 volts, while the OLED is reading 11.2 volts. And then the low range is reading a 1.034 volts, and the OLED is reading a 0.5 volts. In conclusion, I learned a lot with the construction of the voltmeter, not only the physical items necessary for the build, but also the accountability for each step taken. The steps taken with the build, multisim, and LabVIEW has given me a better understanding of the software as well as the hardware. I would recommend this course for anyone who is looking for work in any electronics field. So in conclusion, I am leaving time for questions and answering. Thank you.